In the last session, we have seen what is a flip-flop, what are its application and how to trigger it, and what is the difference between a latch and a flip-flop. So in today's class, we will be seeing about how the RS flip-flop works. Either it is said as RS or SR. Why it is called as SR flip-flop? It is because it is called as a set reset flip-flop. Okay, so this we are going to analyze using a cross coupled NOR gate. Okay, so to understand the operation of your RS flip-flop, we first should know, because since NOR gate is used, so we just analyze certain basic things from the NOR gate so that it is easy to analyze the circuit, right? So now we will go on to your NOR circuit. So what is the NOR gate? So 00011011, it is the complement of your OR gate. So for your OR gate, if either of the input is 1, the output is going to be 1. So here you will have 0, 1, 1, 1. Okay, and your NOR gate is just the complement of it. So you have the output as 1, 0, 0, 0. So if you are going to analyze the NOR gate in one fashion, if I am going to have the inputs, either if I am going to have the one input as 1 or both the input as 1, you could see analyze the output is 0. Okay, only with this concept you are going to analyze the RS flip-flop. Okay, it is nothing but if I am going to give 1, okay, if one of my input is 1 or if both the inputs are 1, my output is going to be 0. Okay, now we will move on to the operation. First we will start with the reset. Okay, what I am going to give? I am going to reset my flip-flop, that is my set signal is 0 and I am going to give the R signal as 1. Okay, so when I am going to make my R as 1, it is called as a reset. I am going to reset my flip-flop. In that case, my output is going to be 0. I am going to reset the flip-flop. Now we will just analyze the condition. Now what is the condition we have derived? If any one of the input is 1, irrespective of the other input being 0 or 1, my output is going to be 0, right? So we cannot analyze this part if one input is 1. Okay, so if one input is going to be 1, irrespective of the other output, it can be either 0 or 1, my output will be 0. Now this 0 is going to be penetrated here. When I am going to have 0, 0, the output is 1. Okay, so what is the inference from this? Whenever I am going to make my reset signal as 1, my output is going to be 0. Okay, what I have done? I have taken my S as 0, R as 1, which means I am going to reset my flip-flop. My output is going to be 0. If any one of the input is 1, output is going to be 0. So that is the condition derived from your NOR gate. So this 0 is going to be propagated here. 0, 0 means 1. You can check the output. If one output is 0, the other output is 1. So they are complementary to each other. So this condition is checked with. Now we will check the next condition, that is your set condition. So we will check the set condition now. So in set condition, what happens? Your set is going to be 1. Your reset is going to be 0. So from the name itself, you should know when set is going to be 1, that means I am going to set my flip-flop. So my Q output will be 1. Okay. Now let us assume the condition. So where I can check? Only in the set signal, because it is having the 1. So automatically my output, depending, no need to consider this. Automatically my output will be 0. Now this 0 will be fed here. So what is the output of the NOR gate? 0, 0 means 1. So what is the condition? When my set signal is 1, my output is 1. That is, I am going to set my flip-flop. Okay. So whenever I am going to reset my signal, it is going to reset my signal as 0. Whenever I am going to set as 1, it is going to set my flip-flop. So only it is called as a set reset flip-flop. Now we will go on to this condition. When my input is going to be 0, 0. Okay, When my input is going to be 0, 0, I cannot predict my output at all. Considering whatever the data I got it in the previous step, because everything is going to be a clock cycle here. It is not going to give the discrete inputs. Okay, all the 4 states are going to be done with internally in a clocked way. So in that case, whenever I am going to 0, 0, I cannot know what is the previous condition. In that case, whatever the previous condition which is obtained in the set condition, I am taking it here. So whenever I am going to give the 1, so what happens? 1 into 0, the output is going to be 0. Now this 0 is going to get propagated here. When both the inputs are 0, the output is 1. Okay, so now what does it does indicate? When my inputs is 0, 0, Qn and Qn bar, I am taking the previous value. Okay, past value. Then in that case, my output is 1 and 0. So it is going to retain the previous state as it is. So it is called as a no change condition. Whenever I am going to have my inputs as 0, 0, I cannot predict my output. So I take the previous output condition and I am proceeding with, I am getting the same state as 1, 0. So this condition is called as a no change condition. Now we will move on to the last circuit, that is your 1, 1 condition. Whenever I am going to take the 1, 1 condition, what will happen? When one input is 1, automatically the other output is going to be 0. So now when this 0 is going to propagate here, what happens? For 0, 1, it is 0. Now this 0 is going to propagate here, 1, 0 is 0. But what is the drawback in this circuit? Both the outputs cannot be 0 because they are complement to each other. So this condition we are not able to discriminate. So it is called as a forbidden condition or indiscriminate condition. So is this clear? So whenever I am going to reset my flip-flop, my output is going to be 0. Okay, whenever I am going to set my flip-flop, my output is going to be 1. Based on the past inputs, whenever I am going to change, it is going to result in a no change condition. Whenever I am going to give my both the inputs as 1, what happens? I cannot discriminate between the outputs. So this is called as a indiscriminate or a forbidden condition. Now we will just see how to draw the pin diagram for your RS flip-flop with different types of triggering. Suppose. So what is your inputs? RS, output is going to be QQ bar. Okay. If I am going to use the clock pulse. So the next thing is so now you are going to draw the pin diagram. What is going to be your inputs? SR, output is going to be QQ bar, and here you are going to have, what is the difference between the two circuits? Here I am using the clock signal, that is here I am putting a bubble, here I am not putting a bubble. So this is a representation of the level triggered SR flip-flop. Okay, for level triggering, with suppose whenever I am going to do it normally, I am not going to put any clock pulse. Okay, whenever I am going to use a NOT gate, it is going to differ at us. This is called as a positive level triggered and this is going to be called as a negative level triggered. Okay, now this if I am going to change it as a edge triggered one. Okay, in edge triggered, if I am going to change it as a positive and negative, in that case what am I going to do is, I am going to put a, when I am going to give this signal, it says that it is a edge triggered flip-flop. If I am not going to use this arrow mark, it is a level triggered positive flip-flop. For a negative, level triggered positive flip-flop, you just put a bubble here. Okay, thank you students. In the next class, we will be seeing about the gated latches. Thank you.